Hi everybody, it's Miss Lorenz here, and I'm going to go through the Lesson 2, Unit 1, 5 problems that you did for practice. So just a reminder, you should have your work out with a correcting pen, something that's a totally different color than the pencil that you use to do your work. Your job is to make your answers better, not just put a star by them if they're correct. In fact, that doesn't even need to be included. I want to see by way of making corrections to your work and by way of making your answers better, adding more to make it better, for example. All right, let's get started. The first one, here are 4 drawings that each show 4 squares inside a shape, and you are to select all the drawings whose squares could be used to find the area of the shape. Well, right off the bat, I noticed this one. Do you see how there's some overlap? Oops, I don't have my pen showing. Do you see how there's some overlap right here? There can't be any overlap. We can't use those squares to find the area, so that one's a definite out. B is also a definite out because do you notice how this unit, this small unit, the smaller unit, and this larger unit are being used at the same time? We can't find a consistent measurement of area if we're doing that. We can do that with A, though, because we're using the same size square and we're not overlapping anything and we're filling up the entire shape. So yes to A. And for the same reasons, yes to D. It's a smaller unit, so maybe these might be measured in centimeters squared, where these might be measured in inches squared, so a different measurement, but it doesn't matter. So yes, that would be a yes as well. All right, number 2, write the definition of area that includes all the information that you think is important. I'm really curious when I look at your papers to see what you wrote down. I said something to the effect of that area is the amount of space inside a 2-dimensional region and that it's measured in square units. And so what I think is important is that it's something about the space inside. You could call that the region inside or the, I don't know how to say the area inside without saying the word area. I think it's important to have something down about square units. So if you didn't do that, make sure that you add that to your definition. All right, let's go to number 3. Priya decomposed this square right here into 16 smaller units. So she took this apart and then she decomposed it into this. And then she took 4 of the squares out of the middle. She put them around the side. And we're to answer or to look at these answers, A through D, and decide which of these is true. So how does the area of her new figure compare with the area of the original? In A, it says the area of the new figure is greater. Well, that is not true. All of these squares have just been rearranged. So they are all here. They're just in a different position. So the area is not greater. The 2 figures have the same area? Yes, they don't. They both have the same area. So this is a good reminder that 2 figures that have the same area could look quite a bit different. The area of the original is greater? No, that's not true. They both have the same area. We don't know because neither the side length nor the area of the original square is known. Well, we actually can tell that they have the same area because we can count each of these unit squares and we can see that the same number of those same size unit squares were used to create this figure on the right. So that's not true. All right, number 4, draw the area of a rectangular playground is 78 square meters. And if the length of the playground is 13 meters, what is the width? So I drew the playground here. You can see that, try to make a different color. You can see that I put 78 inside because that is the area, 78 square meters inside. That's the area of the playground. This side of the playground, the longer side, is 13 meters. And so here's what I'm trying to figure out. 13 times what number? The width is 78. And I know that 13 times 6 is 78. So the width must be 6 meters. Here it says draw if you need to. I draw all the time. Your brains at this age are very visual. So when it says draw if you need to, really consider, like, how can I draw to make better sense of this? It's actually connecting the 2 sides of your brain when you do that. So it's actually really good for brain growth as well. All right, number 5, a student said we can't find the area of the shape, we can't find the area of the shaded region because the shape has many different measurements instead of just length and width that we could multiply. Well, length times width is used when we have a rectangle. This shape, we can find the area of, we would just need to decompose it. So the student is incorrect. Length times width works only if it's a rectangle. We can make rectangles though, so let's make some. This one right here would be a 15, this one right here would be a 15 by, what would that be? 15 and 10, 25? Yep, 15 times 25. This rectangle, how should I have chopped that up? This top one is going to be 35 times whatever this is, and if that whole thing is 30 and this much of it is 20, then that's going to be 10. You could chop it up like this. Ooh, I think you're going to want to chop it up like this actually, and then like this. So we don't actually have to find the area. If you're freaking out right now like, oh my gosh, I didn't find the area, you actually don't need to find the area in this problem. But you do have to explain why the student is incorrect, and that's what I'm trying to do here. You can certainly find the area of this figure by decomposing it. Let's use a different color, and I'll do a better job. By decomposing it, this would probably be the nicest way to decompose it, but there are other ways you can do it. All right, so I hope that helped. Thanks for listening, thanks for watching, and keep up the good work, guys.